In 2012, a neuroscientist at a children's hospital in Toronto trained a group of baby mice to be afraid of a box. The training worked. Every mouse froze the moment it was placed inside. Then he waited 3 weeks. Then he put them back in the box. They walked around like they had never been there. He had not touched them. He had not harmed them. Something inside their own heads had done it. His name was Paul Franklin. The hospital was the hospital for sick children, and he was not studying mice at all. Your earliest memory probably sits around age 3. Maybe a birthday, maybe a car ride, maybe something that hurt. What is almost certainly not in there is anything from your first 2 years. Those 2 years are gone, not faded. Not blurry gone. Most adults assume they know why. The brain was too small. The circuits weren't T-wired yet. You weren't T-capable of forming memories. That explanation arrives quickly. It has the texture of something true. It is wrong. Not partially wrong. The part of your brain that stores long-term memories. You weren't. The hippocampus is already working in the first months of life. Babies form memories constantly. You can demonstrate this in an afternoon. Hang a colorful mobile above a 3-month-old in a crib. Then attach a ribbon from the mobile to the baby's ankle. The baby kicks. The mobile moves. Within minutes, the kicking rate doubles. Return a week later, attach nothing, and the baby kicks anyway. The memory is there. The association is solid. Something is being learned by a brain everyone assumes cannot yet learn. So the memories are being made, and then something is taking them. That was what Franklin was studying. Not memory formation, memory erasure. And the mechanism he found was not a malfunction. It was the normal operation of a growing brain doing exactly what it was built to do. In the hippocampus of an infant, stem cells divide constantly. They produce new neurons. Those neurons grow, extend connections, and wire themselves into the existing network. In the first years of life, this process runs faster than it will at almost any other point. New neurons are not neutral additions. When a new neuron wires itself into an existing circuit, it changes the pattern. An experience stored in one configuration of cells gets partially overwritten when new cells alter the connections. The memory is not deleted cleanly. It is more like building a new road through a field that used to hold a map. The map is still underneath. You just cannot read it anymore. Franklin ran the experiment twice more. In the first variation, he took adult mice with stable memories and artificially accelerated this process in their hippocampi. Those mice began forgetting things they should have retained. The forgetting followed the new growth exactly. In the second variation, he blocked this process in baby mice just after they had formed memories. Those mice walked back into the fear box weeks later and froze. The memory had survived because the construction had stopped. Restart the construction, the forgetting resumed. But a developing brain is not the answer. It is just the first answer. Franklin's work explains the biology of forgetting. It does not explain why the human cutoff lands where it does. The reliable threshold is around 2.5 to 3 years old. That number is not random. In 1993, psychologists Mark Howe and Mary Courage at Memorial University in Newfoundland were tracking something that seemed entirely unrelated. They were studying when children develop a concept of self. The test involved a mirror and a small dot of rouge. Without the child noticing, you place a red mark on their nose, then you put them in front of a mirror. A child who has no self-concept will reach toward the reflection or ignore the dot. A child who understands themselves as a self reaches toward their own nose. The dot is wrong. It belongs to them, and they know it. Most children pass this test somewhere between 18 and 24 months. Howe and Courage then mapped those results against data on earliest autobiographical memories. The match was precise. Almost no one reports a memory from before the month they passed the mirror test. The cutoff on remembering your own life tracks within a few months. The point at which you first understood that you had one. You cannot file a memory about yourself before you know what self means. The hippocampus was running, experiences were being recorded. But there was no folder labeled me. Events were stored as events. Not as your events. A memory that belongs to no one is not something you can retrieve later by searching for yourself. So now you have two mechanisms that reinforce each other. Neurogenesis dismantles the circuits before they can consolidate, and a developing self provides no stable address for memories to arrive at. Together, they explain the timing. They explain the universality. They explain why the cutoff doesn't T-fall at 6 months when neurogenesis is at its peak, but at 2 or 3 years when both processes are winding down at once, the case looks closed, the pieces fit, and that is exactly when researchers started noticing something neither mechanism could explain. Adults from different cultures report different starting points for their earliest memories, not just at different emotional intensities, but at different ages. Adults who grew up in New Zealand report memories from roughly 6 months earlier than adults who grew up in parts of East Asia. 6 months is a very large shift for something supposed to be a universal biological clock. If neurogenesis and the developing self were the whole story, this gap should not exist. In the early 2000s, psychologist Patricia Bauer at Emory University began tracking what happens when parents talk to their young children about shared past experiences. Some parents were elaborative. They told stories. They added context. They connected one event to another. Do you remember when we went to Grandmother S' house and the dog knocked over the lamp? Other parents were sparse. They confirmed facts without building narrative. Yes, we went there. Yes, the dog did that. The children of elaborative parents formed earlier, more stable autobiographical memories. By the time those children were adults, the gap in how far back they could reach was measurable in years. Language is not just how you describe a memory afterward. Language is part of the structure that holds a memory together while it forms. You did not lose those years. They were taken. What was taken was not the experience. What was taken was the structure that would have let you find the experience again. The filing system that neurogenesis dismantled. The self-referential folder that did not yet exist. The narrative that nobody built around the raw footage. The footage is not entirely gone. This is the part that is easy to miss. There is a form of memory that does not depend on language or self-concept or hippocampal filing. It runs in different circuits, and it was not erased. Your body knows how to walk. It knows how to reach. It knows the weight of a familiar object before your hand closes around it. These were all learned in those first years, and they are all still there. You carry your infancy in your hands and your feet and the way you orient toward a voice you trust. You just cannot put any of it into words. Emotional residue from those years leaves measurable traces even when the explicit memory is gone. Adults who experience significant warmth or disruption before the age of 3 show physiological patterns that correlate with those early conditions. The body kept the record. The narrative did not. So what you lost was not time. You lost access. A library you built over 2 years, and then the address changed, the filing system was redesigned, and the key no longer fits any lock you can reach. What you remember of your earliest years is not a fair sample of what happened to you. It is a sample of what someone helped you put into words before neurogenesis reshaped the circuits. The adults around you were, without knowing it, deciding which of your experiences would survive, not out of cruelty, not out of neglect. Nobody understood this 30 years ago. The pediatricians did not know. The parents did not know. The grandparents sitting across from a 2-year-old at dinner, asking only yes or no questions, had no idea they were watching a door close. You are not missing those years because something went wrong. You are missing them because something went right. From the only perspective that counted then, a brain too busy preserving old memories cannot grow fast enough to handle new ones. The neurogenesis that erased your infancy is the same process that gave you the cognitive range you spent the next 20 years using. The forgetting was the price of the learning. The mice Franklin returned to the fear box. The ones whose neurogenesis he had blocked froze when they walked in. They had kept something that normal mice lost, but they had also not grown as fast. Preserving the memory came at a cost he could measure in the density of new circuits. The mice that forgot were the mice that grew. Your first 2 years are not a blank. They are underneath everything you know how to do. The self that reached toward the mirror one afternoon and understood, for the first time, that it had a nose. That self had already been watching the world for 18 months. It had already learned to read faces for safety. It had already associated certain sounds with warmth and others with absence. It had already decided, without words, what the world was likely to give it. None of that made it into the story you tell about yourself, but all of it made it into you.